Welcome to OOTO TV, the out of the office investigation from the past into the future of artificial intelligence. I'm Sue.
And I'm Bob. Today we're investigating a topic that isn't just a buzzword. It's fundamentally reshaping how we build AI, agentic design principles.
That's so true, Bob. Everyone's calling 2025 the year of the agent, and it's for a really good reason. The entire playbook for creating AI is being thrown out and rewritten as we speak. We're talking about a huge leap past simple chatbots and into this incredible new world of AI systems that can actually reason, plan, and most importantly, act.
It is a huge leap, but it's one thing to hear all the hype and another to actually roll up your sleeves and build these things. So today we're getting into the real blueprint, the core patterns you need to create truly intelligent AI agents. And we're drawing from some amazing insights laid out by Sam Bhagwat.
Exactly. We're going to start with the foundation, what an agent really is, and how it's different from what we're used to. Then we'll get into the fun stuff, how to give it superpowers using tools and memory. From there, we'll see how you can manage really complex tasks with structured workflows. And then, this is my favorite part, how you can scale that intelligence by building entire teams of collaborating agents.
And we're going to tie it all together by asking what this all means for building real-world business solutions that actually deliver value. This isn't just theory, folks. This is the future of software taking shape right before our eyes. Let's get into it.
Okay, so let's start at square one with the foundational concept, the agent itself. For the past couple of years, our main way of talking to a large language model has been through a chat window. We type a question, we get an answer. Simple.
Right. It's a very straightforward one-shot interaction. I give it a chunk of text and say, hey, summarize this for me. And poof, it does. But then the conversation's over. It's powerful, for sure, but it's fundamentally limited. There's no memory, no continuity.
Exactly. And that's why the shift to AI agents is such a profound change. We are moving from those little isolated tasks to creating entire systems that are built for ongoing, stateful, and really complex problem solving. And this is the core idea we have to get our heads around. An agent isn't just a simple call to an API. It's an entire system built around that call to give it persistence, capabilities, and a real purpose. And that leads us to the perfect framing question, Sue. Because let's be honest, the term agent is absolutely everywhere right now, but it's gotten so fuzzy. It's become this catch-all buzzword that people use for everything from a simple chatbot to an AI assistant.
Oh, that can be so misleading. There is a world of difference between a model that can answer a quick factual question and a true agent that's designed to accomplish a multi-step, complex goal.
Precisely. So we need to cut through the noise and get specific. What is the actual functional difference here? Because if we, as the builders and the designers, don't have a crystal clear definition in our own minds, there's no way we can engineer these systems to be reliable and effective. We need a much better mental model.
I think this analogy from the source material just nails it. It's the perfect way to frame it. It contrasts a contractor with a full-time employee. A simple direct call to an LLM, that's like hiring a contractor.
Oh, I love this. Okay, so looking at the slide, the contractor gets a one-shot task. It is completely transactional. Write a social media post for this product. They do it, they send the invoice, they're gone. No context retained. They have no idea what you asked them to do 5 minutes ago, and they definitely don't have access to your internal company tools or databases.
Exactly. It's just a simple transformation of input to output. Now look at the employee column, which represents our agent. The interaction is ongoing. They maintain context from one conversation to the next. And here is the absolute game changer. They can use tools to act. We can give them access to APIs, to code interpreters, to our internal databases. This is what elevates them from just transforming text to being true, complex problem solvers that are part of the team, working toward a much bigger goal over a longer period of time.
And that brilliant analogy leads us right to this clear, functional definition. An agent isn't the large language model itself. That's a common mistake. It's an AI layer, an architectural wrapper that we build on top of a foundational model like GPT-4 or Claude.
So let me get this straight. The LLM is the reasoning engine, it's the brain, but this agent layer, that's the scaffolding that gives it all those employee-like powers. It's the part that lets it actually execute code, connect to memory systems, and even talk to other agents. It turns that brain into a functioning actor that can do things in the digital world. This is our fundamental building block right here.
Exactly. And it's so important to understand that agency isn't like a light switch. It's not just on or off. It exists on a spectrum. As we see here, on the low end of autonomy, you've got agents that are basically just navigating a simple decision tree. They make binary choices in a very controlled, very predictable way.
Then you level up to medium autonomy, and this is where things get really exciting. It's where most of the practical, real-world development is happening right now. These agents have memory, they can call external tools, and they have logic built in to retry tasks if something fails. They're starting to show some seriously genuine capability.
Right. And then, way at the top, you've got the holy grail, high autonomy. These are the agents you see in the movies. They can perform complex planning, they can take an abstract goal and break it down into concrete subtasks, and then manage their own task queue. It's basically an AI project manager. But let's be real here. While high autonomy is the super exciting frontier, almost all of the reliable deployed systems in the business world today live in that low to medium range. That's where the hardest and most important engineering challenges are today, making those medium autonomy agents robust, reliable, and secure enough for prime time.
That is such a great point about focusing on medium autonomy, Bob, because an agent, even a really capable one, is just the beginning. Its real power doesn't just come from the raw intelligence of the LLM sitting at its core. It comes from the superpowers that we connect it to.
And the two most critical superpowers are what we're looking at next. You've got tools, which give it the ability to act on the world, and you've got memory, which gives it the ability to learn and maintain context over time.
Without those two things, an agent is just a brain in a jar. I mean, it can think, but it can't do anything or remember anything. With them, it becomes this powerful actor capable of accomplishing real, meaningful work. And this quote from the source material just hammers the point home for anyone out there building these systems. Designing your tools, the most important step.
This represents a massive mindset shift for developers. For the last couple of years, the entire focus has been on prompt engineering. How do you craft the perfect combination of words to get the right output from the model?
But in agentic design, that's almost secondary. The primary skill is now systems engineering. The most critical questions you have to ask are, what can this agent actually do? What specific, reliable functions can it call? How do we give it access to information? And more importantly, the ability to take action.
The quality of your agent is a direct function of the quality of its tools, period. Answering those questions is the difference between a flashy demo that kind of works half the time and a robust, production-ready system that a business can actually bet on.
And this case study of a book recommendation agent just illustrates that point perfectly. Look at attempt 1 on the slide. Total failure. The first approach was what a lot of people try. Just dump a massive amount of raw data, all the book information, into the agent's context window, and just hope it figures it out.
And predictably, it was a disaster. The agent was completely overwhelmed. It couldn't reason in a structured way over that giant, unstructured blob of data. That's like giving a chef a giant pile of ingredients on the floor and just saying, make dinner. It's not going to work.
Exactly. Now look at attempt 2. Success. The developer completely rethought the problem. Instead of raw data, they gave the agent capabilities. They built these very specific, discrete tools, a tool to access investors, a tool to get recommendations, another to sort by genre.
So the agent could now behave like a human analyst would. It could perform a logical sequence of reliable operations to arrive at an intelligent conclusion. This is the absolute soul of good agentic design. Don't just give the agent data, give it tools.
Okay, I'm sold. Tools give the agent a way to act. That's crystal clear. But memory still feels a bit more abstract to me, Sue. The simple approach is just to stuff the entire conversation history into the context window with every turn, but we all know that's not scalable and it leads to errors really fast.
Well, that's a really common misconception, and it's a huge engineering problem to solve. Effective memory is way more sophisticated than that. We can really break it down into 2 main types. Over on the left, you see working memory. This is for storing persistent long-term facts. The source has this hilarious example. Because the author's kids use his account, ChatGPT's working memory has stored the fact that he's a 5-year-old who absolutely loves Squishmallows. It's for those static defining characteristics about a user or project.
Okay, so that's the long-term profile. What about on the right, this hierarchical memory?
This is much more dynamic, and it's much closer to how our own brains work. It's all about intelligently combining what was just said, the most recent messages, with semantically relevant memories from the distant past.
Right, so if you ask me what I did last weekend, my brain doesn't reread the transcript of my entire life. It just searches for relevant events and surfaces them into my current context window for our conversation.
Precisely. And the real engineering challenge, as the source points out, is building processors to manage all of this. You need components, like something called a token limiter, that can programmatically decide which memories are most relevant right now and which ones can be left out to keep the interaction focused, efficient, and under that token limit.
You're listening to OOTOTV with research by author Paul Boulot.
So let's see how this all starts to stack up. We have an agent, it has memory to keep track of things, and it's got a set of powerful tools to perform actions. That's a fantastic start.
But for any real meaningful business process, just giving an agent a box of tools and wishing it well isn't going to cut it. That's like giving a factory worker a wrench and a screwdriver and just hoping they somehow build a car. You need an assembly line. You need a process.
That is the perfect analogy, Bob. You need to orchestrate those tools in a reliable, repeatable sequence. And this is where graph-based workflows come into play. They are the assembly line for AI. They provide the structure that turns a collection of individual agent capabilities into a robust and, most importantly, a predictable application. And these right here, these are the nuts and bolts, the Lego bricks of that assembly line. A robust workflow isn't some free-form, unpredictable agent just thinking out loud. It's a directed graph that you build from these primitives. You have branching, which is incredibly powerful. It lets you take one input, say a new customer support ticket, and then kick off multiple tasks in parallel. Maybe one branch goes and checks the customer's order history while another branch analyzes the sentiment of their message.
Then you have chaining, which is that classic assembly line, right? The output of step 1 becomes the input for step 2. And merging is how you bring the results of all those parallel branches back together to make a final informed decision.
And of course, conditions. This is how you inject if-then logic into the process. A step might only run if a previous step meets some specific criteria. This is how you take messy, complicated, real-world business logic and translate it into a structured, deterministic, and executable AI process. And this brings me to a point that I cannot stress enough for anyone listening who is actually building these systems. When you are creating these complex, multi-step workflows, observability is not a nice-to-have. It is not optional. It is absolutely essential. So why is it so critical, Bob? What makes it a must-have? Because the core reasoning engine, the LLM, is non-deterministic. It's creative, which is its greatest strength, but it's also unpredictable. So the question isn't if your application is going to go off the rails, but when and how. And when something inevitably goes wrong, and it will, the only way you can possibly debug what happened is to have a complete step-by-step trace of the entire execution. I mean, every tool input, every tool output for every single node in that graph. Without that level of observability, you are flying completely blind, and you'll never be able to run this stuff in production. Okay, so we've built a single capable agent. We've given it tools, we've given it memory, and we've put it inside a structured workflow. But this, Bob, this is where things get really, really exciting. What happens when the problem you're trying to solve is just too big or too complex for one agent to handle?
You build a team.
Exactly. The next level of scale and sophistication is to move from a single agent to a full-blown multi-agent system. We're not just hiring one AI employee anymore. We are designing an entire department of specialized AI agents that can work together to tackle tasks that would be absolutely impossible for any single agent. The best way to wrap your head around this is to just think about how humans work together. Imagine the engineering department at a tech company. You don't have one single engineer who does everything from planning and architecture to coding, testing, and deployment.
Of course not. That would be insane. You have specialists. You've got a product manager who defines the requirements, a software architect who designs the system, a coder who actually writes the implementation, and a QA engineer who tries to break it.
A multi-agent system is structured in exactly the same way. Each agent has a very specific role and a detailed job description, which is defined in its system prompt. Each one has its own specialized memory and its own unique set of tools. They're designed from the ground up to collaborate to achieve a goal that is way too complex for any one generalist agent to handle on its own. And to make that team effective, you absolutely need a manager. And a key architectural pattern here is what's called the agent supervisor. This is, for all intents and purposes, the AI project manager.
So the supervisor agent doesn't do any of the actual coding or writing itself? It's more of a coordinator?
Nope, not at all. Its job is purely to coordinate and delegate tasks. It has a roster of all the specialist agents, and it basically treats them like tools that it can call. When a really complex request comes in, the supervisor's LLM brain analyzes that request and decides, okay, which specialist should I call first, and then who should I call next with the output from that first one? It orchestrates the entire multi-agent workflow from a high level. And here's a perfect real-world example of this pattern in action from Replic's code generation system. As you can see, it is a crystal clear assembly line of specialist agents. You have a planning agent to work with the user and architect the solution, a code manager, the code writer itself, and then finally, a code reviewer that validates the output in a secure sandbox environment. Each agent has one job, and it does that one job really well.
It's fascinating, I'll give you that, but I have to offer the contrary view here. This also sounds incredibly, terrifyingly complex. The source material jokes about it being organizational design for computers, but it's not really a joke, is it? This is a completely new and very difficult engineering discipline.
What do you see as the biggest challenges there?
Well, you're not just writing code anymore. You're designing communication protocols, decision-making hierarchies, and even error escalation paths for a whole team of AIs. I mean, how do you manage the communication overhead between them? What happens when one agent hallucinates just a little bit and passes a subtle error to the next one, which causes a cascade failure all the way down the line? The potential for error propagation and debugging nightmares grows exponentially with every single new agent you add to the team. This is a huge, huge challenge.
And your point about complexity is the perfect transition, Sue. We spent a lot of time on the technical how, the agents, the tools, the workflows, the multi-agent teams. But all of this difficult engineering effort has to serve a purpose. So let's pivot to the business why.
Right. Let's connect all these patterns back to delivering real value. How does all this translate into building better products and solving actual business problems?
Exactly. This is where we need to tackle some really critical questions about the practical application and, ultimately, the success of agentic design in the real world. So let's start with the absolute most fundamental question, the one that connects all these dots. We've established that these systems are incredibly powerful, but also incredibly complex. So, Sue, how can agentic design actually succeed as a method for building business solutions that deliver tangible, reliable value, and not just another cool science project? The answer, I think, lies in this key takeaway. Agentic design is a modality to achieve business continuity while achieving rapid growth. Now, I know that sounds a little bit like corporate jargon, so let's actually break down what that means.
Please do. What does that actually mean for a business?
Okay, business continuity means building systems that you can truly rely on. By using these structured, workflow-driven agents instead of fragile, single-shot prompts, you can automate complex core business processes in a way that is predictable, auditable, and reliable. You know it will work the same way every single time. And what about the rapid growth part? That is all about scale. Because these agentic systems are designed to automate knowledge work, they can handle a rapidly growing volume of tasks, things like customer inquiries, data analysis, content creation, without needing a proportional increase in human headcount. It's all about building resilient, scalable automation that can grow right alongside the business.
You're listening to OOTO TV with research by author Paul Bula.
Okay, that makes a lot of sense as the high-level business strategy, but let's get down to the brass tacks of deployment and maintenance. Building a prototype in a notebook is one thing, but running it in production 24/7 is a whole different ballgame. So what are the key elements that agentic design needs to succeed in the real world, day in and day out?
The challenges here are really significant. The source material highlights some great examples. These agentic workflows are often very long-running processes, which can easily cause function timeouts on standard serverless platforms like AWS Lambda. That is a huge operational headache for any engineering team.
And what about just maintaining these things? To iterate and improve quickly, your developers need robust local environments with specialized tools like workflow visualizers and playgrounds so they can test individual tools in isolation. This isn't just about writing Python code anymore. It's a whole new MLOps stack we have to build. So what does a successful, maintainable system actually look like in practice? You're hitting on such a crucial point, Bob. The answer is that agentic design significantly improves quality and assurance when designed as a complete solution. And that phrase, complete solution, is the key. It means you're not just deploying the agent itself. You're deploying the entire ecosystem of tooling and process around it.
And a massive part of that ecosystem has to be testing and evaluation, right?
Absolutely. To handle maintenance and updates safely, a critical component is a really rigorous evaluation pipeline, often just called evals. This is your safety net. Every single time you want to change a prompt, update a tool, or swap in a new model, you must run an automated suite of tests against a golden dataset of examples.
And we're not talking about traditional software unit tests that check if 2 + 2 = 4. We're talking about textual evals, which are often themselves powered by LLMs to check for things like hallucination detected, faithfulness confirmed, or relevancy.
This is how you prevent the system from silently degrading over time. It is absolutely essential for quality assurance. Quality is one thing, Sue, but that brings me to what I think is the single biggest concern for any enterprise looking at this technology: security. We are building agents that are explicitly designed to take actions, to execute code, and to access proprietary company data. So, can we actually make these solutions safe and secure?
And this isn't just a theoretical problem, is it?
Not at all. The source material mentions a real-world vulnerability that was discovered in a GitHub agent that could have allowed an attacker to leak private code repositories and API credentials. The moment you connect an LLM to powerful tools, you are dramatically expanding the attack surface of your application. The risk is incredibly real. It's a massive challenge, Bob. There's no doubt about it. But it is solvable if we approach it with a classic defense-in-depth strategy. The source outlines these 4 key pillars of agent security. The first is guardrails. This is all about sanitizing all user inputs to defend against things like prompt injection and jailbreaking attacks.
Next up is authentication. That's basic table stakes. Who's even allowed to talk to the agent in the first place?
Third, and this one is so critical, is authorization. This is much more granular. Just because I'm authenticated doesn't mean my agent should have access to the entire company database. Authorization controls, on a per-user and per-request basis, which specific resources and tools an agent is allowed to use at runtime.
And finally, if your agent is generating and executing code, sandboxing is completely non-negotiable. You have to run that code in a totally isolated, ephemeral environment to prevent it from ever touching your production systems or doing something malicious. By implementing all 4 of these layers, we can build agents that are both incredibly powerful and safe.
So, to bring this all home, the crucial point is that agentic solution design can achieve success at any scale. Whether we're talking about a small internal tool or a massive enterprise-wide engagement, this structured tool and workflow-based framework is the key to getting it right.
And that's ultimately why agentic agent delivery is critical to achieve business goals. It elevates us from the craft of just writing clever prompts into the true engineering discipline of building scalable, secure, and maintainable software systems that are powered by AI.
A fascinating and complex future for sure.
It truly is, and it leaves us with one final, kind of mind-bending thought to close on. We've spent this entire investigation laying out the human-designed blueprint for building these intelligent systems, but what happens when the blueprint itself starts learning? What happens when these agents begin to analyze their own performance logs and autonomously start redesigning the system and themselves for better performance?
That is a very big question for another day. And that's all the time we have for this investigation from Odo TV. Join us next time.